voltage, or potential difference. Electric potential is the electric potential energy per unit charge. I know it sounds really funky, bear with me. It's a scalar, the units are in volts, and it's zero only at infinity for a single point charge. Right, until you get infinitely far away from a point charge, your potential energy is never going to be zero. Now, here's the good news about this. We don't ever have to calculate this in this course. This is reserved for AP Physics 2, but this is the connection between force, electric field, and electric potential energy. And, that volts thing sounds a lot like voltage, and that sounds like something we're going to need in circuits. So here's the thing. I can set electric potential equal to 0 wherever I want if I'm working with just the difference in potential between 2 points. This is like when we studied gravity, and I could set my gravitational potential energy 0 anywhere, like say the tabletop, if everything's at the same level and all I care about is the height above the table. Okay? So what we call voltage is actually more properly called the difference in electric potential at 2 points. Now, electric potential is not energy. Remember, it's energy per unit charge. So if you wanted to write this in units that we've seen before, you could call it joules per coulomb. All right, and voltage is actually a delta V, which is the electric potential difference between two places. Usually when we're dealing with circuits, we're going to drop the delta and just write V as voltage. But if you continue on in physics, please know that voltage is actually a potential difference. Okay, let's look at batteries. This is something that's rated in volts, and, let's see, we definitely use those to power circuits. We'll get there next week. But what a battery does is it converts chemical potential energy to electric potential energy. So one end has an arbitrary value of 0 volts. Okay, so that's where I'm determining my 0 point is. So that's what we call the negative terminal. The other end is whatever the difference is from the other side. If I have a AA battery, that's 1.5 volts. If I have a car battery, that's 12 volts. Okay, so from the negative terminal to the positive terminal, the potential difference is 1.5 volts. So that's what we call the voltage of the battery. So we're going to begin using a water analogy for circuits. So we saw current previously, and it's the flow rate at a given point within a circuit usually. The resistance is based on the physical properties of whatever the current's flowing through, and it is a measure of how easy it is for current to flow through that particular pipe. A battery, or some other voltage source in a circuit, is essentially a pump that you could use to increase the potential energy. I don't know how many of you have ever been to the Schlitterbahn, but if you go up one of the water rides, then you have to use a pump to get the water up there to carry you down again. So the battery in a circuit gives that water potential energy, or gives that charge potential energy.